All right, so dealing with story word problems with quadratic equations, everyone should have read through all of those. Now I want you to focus on the first sentence of each of them. Okay? I want you to draw a picture of the shape they're talking about in each. All right. So what shape do we have for all of them?
Rectangle.
Yeah, a rectangle, right? So, in our first one here, we have our rectangle. And I want you to just underline that first sentence because that's a key on each of these. And as I work with students through these, usually, if they can get down this first sentence, they understand how to go through and utilize that with their shape, then it makes the problem a lot easier. Okay? So everyone's got their rectangles, and I know I'm just kind of sketching some quick ones, and they're not geometrically perfect and everything. However, all right. Good? So, in each one of these, number one, the length of the rectangle is 1 less than 2 times the width. Number two, the width of the rectangular mural is 5 less than the height. Number three, the width of the dock is 4 less than the length. Number four, the width of the photo is 5 less than the length. Number five, a rectangle is 4 times as long as it is wide. And 6, a rectangle is 4 centimeters longer than it is wide. Okay, now as you're looking through these, when you read through these types of problems, there's usually something that, or one of your variables depends on the other. So like this first one, when they talk about length and width, one of these two, either length or width, depends upon the other. Okay? And so when it says the length of this is 1 less than 2 times this, that means we need to know this first. We need to know the width first. And if we have to know the width, that means that's going to be our variable. Okay? It's like in number 2, read through it, circle what you need to know first. You need to know the width or the height first. Okay, tell your neighbor, does the width depend on the height or does the height depend on the width in this one? Which one do we need to know before we can find the other? Okay, how many say height? How many say width? The answer is height. You need to know the height before you can figure out the width. If we know the height, the width is 5 meters less than the height. So we have to know the height first. So I'm putting that in as my variable. Okay, I want you to read through number 3. Circle the thing that you need to know first. Toki, do number 3. Stay with me. I'm trying to get you to understand. Go on to number 3. Okay, tell your neighbor, width or length. Okay, who says width? Length? Answer is length, yes. The width of the dock is 4 meters less than the length, so we need to know the length in order to find the width. Okay, if we know the length, then we can take away 4 and find the width. So we need to know the length. All right, number 4, 5, 6. I want you to circle what you need to know first and label it in your picture, please. All right, number 4, the width of the photo is 5 centimeters less than the length. How many say we need to know width first? Length? Length is true. We need to know the length. Number 5, width or length? Who says width? Length? Good. Width. Okay, and 6, width or length? Width. Good. Width. All right, so we need to know those things. If you can get that down and understand just that one little statement, makes this problem a lot easier, because what happens then is if we go back up to number 1, that means this right here, we're going to have a single variable. If the length is 1 less than 2 times the width, actually let's do that one last. That's the toughest one on here, I think. Let's try number 2 first. Okay? The width of it is 5 less than the height. So that means this width, if I'm going to write it in terms of height, tell your neighbor how you could write that expression right here. Width is equal to, you can only use the variable h here to figure out the width. So Patrick, if I tell you I know the height, how am I going to get to the width? Good, I'm going to subtract 5. That is my width. Okay, I know the height, so I'm going to subtract 5, and that tells me this width. All right? Let's try it for 3. The width of the dock is 4 meters less than the length. So I know the length. From my length, how am I going to manipulate this to label it the width? Okay, tell your neighbor what you did. Parker, what'd you do? You took away 4. All right. How many got that? Well done, eh? I want you to do that for 4, 5, and 6, please. 4, 5, and 6. I'll be walking around if you need help. All right. Jennifer, what'd you get for 4? L minus 5. All right. Jaden, what'd you get for 5? Yeah, width times 4. 4W. Another way we could write it. Right? Excuse me. Bobby, what'd you get for 6?
W plus 4.
W plus 4. All right. How many got those? All right, let's go back up to the first one, which happens to be our toughest one. Go ahead and try that one. All right, who wants to give that one a go? TT, what do you got? 2W minus 1 is what TT says. Who agrees? All right, very good. I want you to now talk to your neighbors and tell them how you're going to solve those problems. All right, hey, everyone's back up here. The area of the rectangle is 45. Find the length and width. So what do? We've done the hard part. We've got it set up. So if I'm finding area, how do I do that? Huh? Yeah. Area of a rectangle is equal to length times width. That's our formula. Right? And so now we just plug in the pieces we know. Do we know the area? Yeah, what is it? 45. So that A becomes 45. Okay, the only reason I put parentheses around it is because I'm inputting it for A. Okay, do we know the length? Yeah, we know the length. It's this, right? We're calling it 2W minus 1. Do we know the width? Yeah, what are we calling it? W. Now, you don't notice how I put all those parentheses in? I do that because that's the math-ese behind it, but really you could just write it as 45 equals 2W minus 1 times W. All right? So now if I want to solve that, I need to figure out how to go about doing that. Well, this is a quadratic. How do I know it's a quadratic? All right. Talk about it. How do we know it's quadratic? I'm not just going to give the answer. Out of half of us, Annalise the only one that volunteers. All right. Go ahead, Annalise.
Well, because if you multiply 2W, you get
2W squared. Okay, so there's our quadratic piece. What else do I need to multiply by? Brennan? Yeah, I got to go W times negative 1 to get negative W. All that equals 45. How do I solve a quadratic? Yeah? No, one step before that. Remember yesterday, right? Look at your steps. Got them on the board still. Everyone should have them. Keegan?
Subtract the 45.
Subtract 45. Set it all equal to? 0. Okay? There we've got it. And now, try to pull out a greatest common factor. Anything that goes into 2, 1, and 45? Other than 1? Nope. So we've got it set equal to 0. We tried to pull out a greatest common factor. We can't do that. What's the next thing you do? Cool. Factor. Okay? Tell your neighbor the first step in factoring about. All right. right, Chelsea, what do I do first? You want to help her? Right? Yeah, yeah, we'd go well, we can't pull the 2 out. We got to multiply the 2 by the TT? A and C, 2 by 45. That gives us negative 90. Then we're listing our factors of negative 90. What are we trying to make? Yeah? Trying to make negative 1. So if I go through these and I start listing them, now some of you are getting very disheartened. You start doing this and you're like, this is taking forever. I like 1 times 90. That's not going to work. Okay, and I go 2 times 45, and I tell you to do that to make sure that you guys you're keeping order, you're keeping track of what you're testing. But if you know, like right here I'm 90 units away, and here I'm 43 units away, really if I'm trying to get a negative 1, and both of these have to be opposites, you have to be 1 unit away, right? Can you think of 2 numbers that multiply to make 90 that are 1 unit away from each other? Jake? Yeah, 9 and 10. Good. So you could just, like if you could think of them right away, dude, you got it. 9 and 10. Okay, which one's positive and which one's negative? Mackenzie? Yeah, 10 has to be negative because you need more negatives than you do positives. Okay, so we got it there. We now factored it. All right, so on this we have W plus 9, W minus 10. Okay, what do we have to do to finish that? It's the last piece of factoring. Mackenzie? Yeah, divide. Good. Divide by that 2. Okay, that gives me 2W plus 9. Unfortunately, my work's going to carry over into this next problem. Sorry. 2W plus 9. All right, we bring that 2 out in front. And what's this back one? Very good. All equals 0. So what could our width be? It could be, what's this give us? Okay, 5. What's this one give us? Yeah? Negative 9 over 2, right? If we have the number out in front, we got to divide by. Can we have a width that's negative? No. Like we can't have a negative length or width, right? When we're measuring, you don't pull out your tape measure and go, well, that's a negative 5. That doesn't work. So this doesn't work. We just throw that one out. It's nonsense. This one's our answer. Our width has to be 5. And that is 5 what? Does it tell us here? Centimeters, yep. Yep, we're at centimeters. Okay, and we could always check it, right? If that's 5, and this is 2 times 5, 2 times 5 minus 1, that gives us 10 or 9. So 9 times 5, is that 45 centimeters? That is. We're good to go. Answer is 5 centimeters. All right. Your goal, finish up this page. Okay? That's your assignment today. For those of you who haven't finished yesterday's work, you have through the weekend to finish that. Okay? It'll be due Monday. No, just the back. Just that one side. Okay? All right? So, if you are sitting there going, yes, then that means you really need to put in the time this weekend. Don't get here Monday and go, oh, I didn't do it. Okay? Because we're going to be doing our test next week, man. Yeah?
On number 2, do you act like the height is the width?
Yeah, good question. So on number 2, yeah, if you're dealing with this, it's the same idea. We could think of it as another way of saying area is like your base times your height. So this would be our base. This would be our height. So you could think of it that way. Oops, not W or 8. Or W would be H. Base times height. So yeah, our height and our base. Okay, good question. All right, go at it. Have everyone's attention up here, please, real quick. Guys, remember the actual question on this one, on number 1, says find the length and width. So we found the width. So we really should label W equals 5 centimeters, and L equals, what would our length be then? Did we figure that already? Yeah, we had it as 9, so 9 centimeters. So make sure you label both on them, right? So 5 by 9. Okay. Hey, I've hung the answers up there if you want to check and see how you're doing on them. Okay? You can. Works up there as well.